Picture one huge old mansion turned into apartments. Dozens of families live under the same roof, sharing the same foundation, the same water main, the same electrical supply. Yet each family has their own locked door, their own private rooms, and no way to peek into anyone else's space. A careful building manager handles the shared plumbing and power behind the walls, so every tenant just gets a clean, working home and never deals with the messy machinery. They each feel like they have a whole house to themselves, even though it is really one building sliced into private units. That is exactly how a single physical server in an AWS data center is split into many separate machines, a trick called virtualization. AWS owns racks of powerful physical servers, but most customers need only a slice of one. To rent those slices profitably, AWS must split a single machine into many isolated virtual servers, give each fair access to CPU, memory, network, and disk, and guarantee that one tenant can never read another tenant's data, all while losing almost no performance to the overhead of sharing. The answer is virtualization run by a hypervisor, software that sits between the physical hardware and the guest operating systems. The hypervisor creates virtual machines, each believing it owns a whole computer, and schedules them onto the real CPU cores. Classic hypervisors do this all in software, which steals performance. AWS solved that with the Nitro system, a design that moves virtualization work off the main CPU and onto dedicated hardware cards, so almost all of the physical server's power goes to customers. A physical EC2 host runs the Nitro hypervisor, a thin layer based on KVM that creates and isolates guest virtual machines. When you launch an instance, AWS places your guest on a host with free capacity in your chosen availability zone and assigns it vCPUs, each mapped to a hardware CPU thread. The hypervisor uses the CPU's built-in virtualization features, like Intel VTX, so guest instructions run directly on the real cores instead of being emulated. Memory is partitioned with hardware page tables, so each guest sees only its own RAM, and the chip blocks any access outside that range. Nitro cards, separate hardware on the host, take over networking and storage, encrypting traffic and talking to EBS volumes without using the main CPUs. A hardened Nitro security chip controls the boot process and removes the need for AWS staff to ever log into the host operating system. The hypervisor time slices vCPUs across guests, and for shared instance types it enforces fairness so one noisy tenant cannot starve others. When you stop the instance, the hypervisor wipes its memory and frees the slot for the next customer. Suppose you launch an M6i large with 2 vCPUs and 8 GB of RAM. Behind the scenes, it might sit on a host with 64 physical CPU threads and 512 GB of RAM, shared among many tenants. Your 2 vCPUs are 2 of those 64 threads. Your network packets flow through a Nitro card that handles encryption and the virtual network, freeing your vCPUs for your application. Because Nitro offloads this work, a Nitro instance delivers nearly the same performance as if you own the bare metal, which is why AWS can also sell whole hosts as bare metal instances using the same platform. Many people believe an EC2 instance is a full dedicated machine. Unless you specifically buy a dedicated host or bare metal type, you share a physical server with other customers, kept apart by the hypervisor and the CPU's hardware isolation. Another myth is that virtualization always carries a heavy performance tax. With hardware-assisted virtualization and Nitro offload, the overhead is now only a few percent. People also confuse a vCPU with a physical core, but a vCPU is typically one hyperthread, so 2 vCPUs often share one physical core. Like that mansion carved into private apartments, EC2 splits one physical server into many isolated guests using a hypervisor plus CPU hardware features. An AWS Nitro system offloads networking, storage, and security to dedicated cards so customers get almost the full power of the machine. I publish a deep cloud breakdown every single day, so subscribe to Tech with Joel and finally understand the machines behind your apps. Would you ever pay extra for a dedicated host, or is shared fine for you? Subscribe to Tech with Joel.